At hour 12, your liver runs out of stored glucose and switches fuel sources entirely. At hour 24, your cells begin breaking down and recycling their own damaged components. At hour 48, your immune system starts to reset. At hour 72, your body has entered a state of cellular repair that most people will never experience in their lifetime. This is not starvation. This is one of the most precisely orchestrated biological sequences a human body is capable of running, and it begins the moment you stop eating. In the next few minutes, we are going inside the body, organ by organ, hour by hour, to show you exactly what happens during a 72-hour fast. Hours 0 to 12, the glucose burn. It starts the moment your last meal is digested. Your blood glucose levels begin to fall. The pancreas detects the drop and reduces its output of insulin, the hormone responsible for pulling glucose into your cells for energy. As insulin falls, the body turns to its short-term energy reserve. Stored inside the liver and muscle tissue is glycogen, a dense, compact form of glucose that the body holds in reserve for exactly this situation. The liver begins breaking glycogen down and releasing glucose back into the bloodstream to keep your organs and brain supplied. During these first 12 hours, most people feel nothing unusual. Energy levels remain stable. The brain continues running on glucose. The body is simply drawing from a reserve tank it has been filling every time you eat. But that reserve tank has limits. The liver holds roughly 70 to 100 grams of glycogen. Muscle tissue holds more, but muscle glycogen cannot be exported to the bloodstream. It is local fuel only. At the pace the resting body consumes energy, the liver's glycogen stores will be significantly depleted within 12 to 16 hours. When that happens, everything changes. Hours 12 to 24, the metabolic switch. With glycogen stores running low, insulin levels now at their lowest point, the body faces a choice. It can break down muscle tissue to manufacture glucose, a process called gluconeogenesis, or it can switch to an entirely different fuel system. It chooses both, but increasingly, it chooses fat. The liver begins pulling fatty acids from adipose tissue, your body's fat stores, and converting them into molecules called ketone bodies. Ketones are an alternative fuel source that the brain, heart, and muscles can all run on effectively. This transition is called ketosis, and it is one of the most significant metabolic shifts the human body can make. As ketone levels rise in the bloodstream, the brain begins adapting its fuel intake. Neurons that have run on glucose their entire life begin accepting ketones as an energy source. This transition is not always smooth. Many people experience what is commonly called the fasting dip around hours 16 to 20. Mild brain fog, low energy, irritability, a dull headache. This is not the body failing. It is the brain mid-transition, briefly running below optimal fuel supply as it adjusts to the new source. Something else happens around this window that most people find counterintuitive. Hunger peaks and then fades. Ghrelin, the hormone that drives hunger signals, spikes sharply in the first 24 hours. But as ketosis deepens and ketone levels stabilize, ghrelin output begins to moderate. The body, recognizing that fuel is now available from internal fat stores, begins to quiet the hunger alarm. Many people report that by hour 20 to 24, the intense hunger of the early fast has passed, replaced by a calmer, clearer-headed state. Hours 24 to 48, autophagy activates. This is the phase most people never reach, and the one that has driven a decade of research into fasting and longevity. Around the 24-hour mark, with insulin at its lowest and the body running cleanly on ketones, a cellular process called autophagy begins to activate at scale. Autophagy means literally self-eating. Inside every cell in the body, there are damaged proteins, dysfunctional organelles, and cellular debris that accumulate over time. Under normal fed conditions, with insulin elevated and nutrients constantly arriving, the cell has little incentive to deal with this internal waste. But when nutrients disappear and insulin drops, a critical cellular sensor called AMPK activates, and another called mTOR is suppressed. This shift signals to cells across the body that resources are scarce. The cell responds by turning inward.
specialized structures called autophagosomes form around damaged cellular components, engulf them, and deliver them to the cell's recycling machinery, the lysosome, where they are broken down into raw materials and reused. The cell is cleaning itself, not randomly, not destructively, with remarkable precision, targeting damaged and dysfunctional components while leaving healthy structures intact. This process runs continuously at low levels during normal life, but during extended fasting, autophagy accelerates significantly, running at a scale and intensity the body cannot achieve when it is constantly processing food. Alongside autophagy, two other significant changes occur in this window.
Growth hormone, the hormone responsible for tissue repair, muscle preservation, and fat metabolism, spikes dramatically during extended fasting. Some studies have recorded increases of over 1,000% above baseline during multi-day fasts. This spike is the body's mechanism for preserving lean tissue while it draws energy from fat stores. And systemic inflammation markers begin to fall. With insulin suppressed, inflammatory signaling pathways that insulin activates are quieted. Many people with chronic low-grade inflammation report a marked reduction in joint pain, bloating, and general systemic discomfort during this phase of an extended fast. Hours 48 to 72, deep cellular repair. By hour 48, the body is operating almost entirely on internally sourced fuel. Fat stores are supplying the majority of energy via ketones. Gluconeogenesis in the liver is producing a small but steady supply of glucose for the tissues that still require it: red blood cells, certain kidney cells, and small portions of the brain. Autophagy is now running at peak intensity. The gut, relieved of the constant work of digestion, has entered a rest and repair state. The intestinal lining, which normally turns over rapidly due to the mechanical and chemical stress of processing food, is undergoing accelerated cellular renewal. In the immune system, something remarkable is happening. Research has shown that extended fasting triggers a significant reduction in circulating white blood cells in the short term, particularly certain older, less effective immune cells. This initial drop is followed by a regenerative signal. The body begins producing new immune cells from stem cell precursors. The immune system is not being depleted. It is being partially reset. Old and damaged immune cells cleared, new cells produced to replace them. A process that functions at a biological level, similarly to how autophagy functions at the cellular level, clearing out the old to make way for the new. The brain at hour 72 is running almost exclusively on ketones. Many people who complete extended fasts report a striking mental clarity during this window, sometimes described as the clearest thinking they have experienced. This is consistent with what is known about ketones as a brain fuel. They produce less inflammatory byproduct than glucose metabolism and may support higher sustained cognitive output under certain conditions. The body has adapted completely. It is no longer searching for food. It is no longer in transition. It has entered a stable, efficient, internally resourced state, and it is using that stability to repair. The refeed, why the first meal matters. 72 hours of fasting ends not with the last hour, but with what comes next. Refeeding after an extended fast requires care. The digestive system, having been at rest, has reduced its enzyme output. The gut lining is in a sensitive state. Insulin sensitivity is at its highest point, meaning the pancreas will respond sharply to incoming carbohydrates. Introducing large amounts of refined carbohydrates or heavy meals immediately after a 72-hour fast can cause a rapid insulin spike, digestive distress, and in extreme cases, a dangerous electrolyte imbalance known as refeeding syndrome. The body that has spent 3 days in a state of careful internal resource management responds best to a careful, graduated return to eating, beginning with easily digestible foods that reintroduce nutrients without overwhelming systems that have been running quietly in the background. The refeed is not an afterthought. It is the final phase of the process. What the body does across 72 hours without food is not a crisis response. It is the activation of systems that exist precisely for this purpose, systems that evolved over hundreds of thousands of years, during which food was not guaranteed, and the body learned to use scarcity as a signal to clean, repair, and rebuild. Whether fasting is right for any individual depends entirely on their health status, medical history, and the guidance of a qualified professional. This video is not medical advice.
It is a window into the biology. But what the biology shows is this: your body knows exactly what to do when the food stops. It has always known. Take care of yourself. I'll see you in the next one.